Hey guys, welcome to CS Talks. My name is Chintan and today we are going to talk about algorithms. What is an algorithm? In general, it is a defined steps to achieve something. For example, let's say you want to cook some dish at home. What you are going to do? You are going to follow some kind of recipe, right? So what is that recipe? Recipe is defined steps to add the ingredients to prepare the dish. So here recipe is your algorithm. Algorithm's definition is quite same in computer science also. In computer science, algorithm is defined steps or guidelines to perform some action to achieve our development goal. For example, you have given an input array of integers and you need to find the maximum number from that array. What you are going to do, you are going to go through that array and find the maximum number. Those steps are your algorithm. So why to study algorithm in computer science? In order to make an algorithm, you need to perform certain actions like sorting, searching to get an intended output. Now every action have different strategies to perform that actions in computer science. So to make an algorithm, you need to perform certain actions. For those actions, you have different strategies. So to make an algorithm with efficient strategy is all about algorithm in computer science. There are some fundamental actions which you are going to use most frequently in most of the algorithms. First action is sorting. By name, you can sort your data ascending or descending. There are so many strategies you can use. One is a merge sort, quick sort, selection sort, bubble sort, and so on. Second action is to searching the data from given input. There are some actions like linear search, binary search, and so on are available in computer science to do this action. Third action is iteration. Let's say you want to loop through data until you meet some condition, then you are going to use the iterations. And you can use the for and while loop strategies to use the iteration. Fourth is recursion. Let's say you want to do the same operation repetitively with the previous outcomes, then you are going to use the recursion. Method call itself. And the biggest example for this recursion is Fibonacci series. Fifth is traversal. Let's say you want to go through all the data in your given input, then you use the traversal action. In traversal, for example, if you have array, then you use the linear traversal. In tree, you use the pre-order, in-order, or post-order traversal. Last but not least, it's memoization in dynamic programming. Suppose you are doing some kind of recursion in which you are calculating same things repetitively, then you don't want to do that. You want to store that result somewhere and then use that later. So now you know about all the fundamental actions which can help you in making an algorithm. I'll give you 3 steps to simplify the algorithm making process. First one is write down the problem statement, input and output. Second is what are the actions required to achieve that output. Third one is what are the available strategies to perform those actions and which strategy is good fit for your problem statement. So one more aspect is required to consider while making an algorithm, and that aspect is complexity. First thing is time complexity. How fast your strategy is to perform certain action in your algorithm is based on time complexity. Second thing is space complexity, meaning how much extra memory your strategy is consuming while perform certain action in your algorithm. Those two things are very important, and it is also related to data structure. So watch my other data structure video and you will get to know. Next, I'll show you a demo for LeetCode problem 344 and show you how to follow those 3 steps while making an algorithm. 344 from LeetCode. It is reverse string. I'm taking a very basic example so you can understand the approach, and then we can go for the complex problems. So there are 3-step process which I already told you in the video. The first step is what is the problem and what is the input and output. So the problem is reverse the string, and we have given the input is character array which is equivalent to string, and output is we need to reverse the string and return the output. Now the second step is important. What are the actions we require? So I am keeping here 2 options. So let me do the option 1 here. Option 1. In this option, what we are going to do is we are going to go through the array. So it is like iterating through array in reverse. So from last element in the index, from last element in the array to the first one. And then what we are going to do is we are going to storing each element in another array and then return that array. So that is the option one. You iterate through end element to the first element and then store it in some extra space, extra array, and return that thing. But if you have read the question here, we need to do the in place operation. So we don't want to use the extra memory here. So we need to work on the option 2 here. So option 2 can be that you use the 2-pointer approach. So I'm going to use the 2-pointer approach here, where we are going to keep the first pointer. So let's say p1 at 0 index, meaning at the start of the array, and we are going to put the second pointer at the end of the array, meaning length -1. As you know, array is always work on the 0 based index, so I am putting length -1 over here for the last element. And then what we are going to do is iterating both pointers in the reverse direction, meaning inside the array direction. So first like iterating both the pointers in the inside array direction, meaning p1 is going right hand side and p2 is going to be left hand side, right? And then how much we need to iterate? So we need to iterate until both pointers meet in the middle, right? And then what we need to do at every iteration, we need to do is swapping the elements. So swap the element values in that array. So over here I am taking example that there is a string called get. So what it's going to do, we will have in the form of array. So I'm just taking like this, and we are going to start with G and E as pointer 1 and pointer 2. Now we are going to swap the pointer 1 and pointer 2, so it will be E, then A, T, G here. Now the pointers will go increment in the direction in the array. It means pointer 1 will increase and pointer 2 will decrease. So now it is at A and T, and we are going to replace that. So E is going to be at same place. Now we are going to have T here, A here, and G here. Now both the pointers are met in the middle, so we don't need to further go and iterate the array, and our result is here. So our result is ETAG. That is our result. So option 2 is better, as we need to do the in place reverse here, and I'm going to use that. So now here we need to identify the actions in our approach, right? So first of all we are going to use the 2-pointer, so that is pretty straightforward. Second thing is iteration here. So I'm just writing here that this action we have identified as iterate, right? We need to do the iteration over here. And the third action is the swapping, which is a pretty straightforward operation. And the last option is we need to return the array, right? So let's find out here that what are the things we can do. So for iteration there are two strategies available. One is for loop looping, and second is while loop strategy, right? So in which one we should use? So here you can use both strategies, but let me give you just insights that when to use for and when to use while loop. So when you know the number of steps, then you use the for loop. And when you don't know how much steps you are going to iterate, so no defined steps from the start, then you are going to use the while loop. Now both have condition stopping, so you can add a condition to stop the loop. So you can use both for that, but this is the thing, right? If you have predefined number of steps for the iteration, then you use the for loop, and you have index based approach. And if you don't have predefined number of steps, then you use the while loop. Like you have certain internal conditions, based on that the loop is going and going, then you use the while at that time, because you don't know how many number of steps you are going to do. So this is how you approach to making algorithm process. And this step, like step number 2, it's going to be different for all the problems. So what you can do is you can keep practicing different problems. You can try to find out a very naive steps approach, and then after that what you can do is try to identify those actions from that steps. And those actions, then you need to define that, okay, which strategy you are going to do. So for example, let's say I need to do any kind of sorting, then I would check here that, okay, I need to sort the data, what are the strategies available. So I can use like merge sort, I can use quick sort, and so on. So those different kind of strategies will help you here. So do detailed study about all different strategies for those actions, and then you will be good at algorithm making process. So this is how you follow the algorithm making process. I know every problem have different algorithms, but remember one thing, every algorithm have set of actions, and every actions have set of strategies. So you just need to follow that path and find your correct strategy and build your algorithm. Thanks for watching the video. Please like and share my video and subscribe CS Talks. Thank you.